As you might recall, I said I needed to characterize these batteries. I needed to find out how much current draw they had just sitting here, out being used to find out how long their shelf life is. The one I tested came out to about 67 days using the math of drawing the current. So what I did was I've already tested this one, and it was 0.015 milliamps, which is tiny. Very tiny. It's 150 microamps. That's great. I don't even know how long that is, but it's way months and months and months. This one, let's take a look here. It lights up. That's good. Next step is to, let's see. Next step is to measure the current. Let me hook that up. Alright, so what I've done is I've connected up the current meter. It's hard to tell, on the very last lead in the back, and you have to hold it for a while because the thing won't turn on unless you let it sit for a while. So I had to let it sit for a few seconds, maybe 20 seconds. So now it's running. If I push the button, the lights comes on, which I can't do, I don't have enough hands. But it starts out about 49 milliamps, and then as it boots up, it drops down to 22 milliamps. I'm sorry, 0.22 milliamps. Doesn't sound like a lot, but if you do the math, it's probably 3 or 4 months, maybe 5, something like that. So I'm going to disconnect this board and reconnect that one behind it and show you how low that value is. Okay, so remember 0.22. Okay, so here we are with the second board installed. Now I didn't have a separate LED to turn it on connected, so I had to hook up the whole bottom of a battery to it. But anyway, so now it turns on, and ironically, it's about the same current draw, 0.23 milliamps. In rehearsal, the first time, it was 0.015. It was very low. Well, the other day, the one I tested was 0.8, and that was 67 days. So this is 4 times better. So what's 67, 60 days times 4, it's 8 months, 9 months, it'll go. That still doesn't sound long enough to me, but the circuit has to have something to keep it alive. So anyway, these boards apparently match, but in rehearsal that's not what I got. Oh, you know what it might be? I might have just connected one of the front ones. This is the total system current. This is connected on the 20 volt circuit across the board, and it's total current. So yeah, I think that's what I did. I hooked up, see that blue connector right there? That blue jumper? I took that off and put the amp meter in there, and it read 0.015. So that makes sense. So anyway, total system, that's the negative back there where I have this probe, and the positive is right there with the green probe in the middle of the screen. That's 20 volts across there. So anyway, these two boards are, I'd call these probably typical. That's my guess. 2 of them in a row, same vintage, and they come out the same, which is really good news. So what needs to happen is this board here doesn't work. It's a much later board, but not the latest, but it doesn't work. It won't spin a drill, and it won't turn on the LEDs, so I think what I'll do is, the cells aren't very high capacity at all, but they all match. They're all in pretty good shape. They're just not very high capacity. So I should qualify that. They're functional. They're probably 2/3 of normal. Instead of 1300 milliamps or 800. So this would make a nice shorty pack, one of the light duty ones. And so I'd have to take all those cells off that one and spot weld them over on this one. And in a previous video you saw my spot welder, so that's not hard to do. Anyway, so this gives me this guy here and this guy here if I want to build some short packs. I don't really, short pack's great to have one if, like I said the other day, if you got a long funny reach and you need the lightest drill possible or the lightest impact possible, this is what you use. I'd rather build them double height, because double height has lots more power, and the cells don't get discharged as far because they have so much more capacity. Now, yeah, if If you keep beating on them in a day, yeah, you could discharge them way down, but it's harder to discharge them down when their capacity is so high. So these use 1300 milliamp cells, and the later versions, the one that says 4 amp hour on the package, uses 2000 milliamp hour cells, but use 2 in parallel, so that's 4000. So this one a lot of times is what, $89, $99? This one's like $59. So this is not as good of a deal. Yeah, it costs less, but you get 1300 compared to 4000. It's a third. It's a third the capacity for 60% of the price. But like I said, if you need one for light, funny work somewhere, you know you need one, and that's okay. But I got to build mine, and this one's not even 1300. These are all, I tested them all around 800. So anyway, that concludes this chapter. I will swap these over and test it and let you know how that goes. See you, bye.